Hello, my name is Dr. Melissa Middlebrooks. I'm an educational coordinator at Georgia Power. At Georgia Power, we make, move, and sell electricity. Today, we will be talking about the transformation of energy. Georgia Power must find resources that will allow us to provide efficient, reliable, and cost-effective electricity to our customers. We transform those fuel resources through a process called transformation of energy. One scientific law called the law of conservation of energy tells us that we can neither make nor destroy energy. We can only transform it. There are many ways to classify transformation of energy, but one of the most is potential, which is stored energy, versus kinetic, which is energy and movement. Our Georgia power plants use natural resources such as coal, uranium, which is used in our nuclear power plants, and biomass such as switchgrass and wood pulp to heat up water to create steam. That powerful steam is then used to turn a turbine blade, which spins the electrical generator to produce an electrical current, which we call electricity. In our natural gas plant, something similar happens where we use gas and high temperature pressurized air to move through our turbines and spin the generators. In our hydro plants, we use gravity and water to create electricity. Water is stored in dams and is released, and that movement of the water turns the turbines to spin the generator. We store these natural resources in their potential state. They remain in that state of stored energy until we either burn them, release them through fusion, or add movement such as water in the hydro plants. This allows for energy to be transformed into the movement of energy, which is called kinetic energy. Today, to help demonstrate how potential or stored energy can be transformed into kinetic energy, we're going to be constructing balloon rockets. And my son Jeremy is going to be helping us. The materials that we're going to be using, as he's coming on in, the materials that we're going to be using are string. You need about 6 feet, balloons, straws, and tape. Now, in order to conduct this experiment, what we want to do, Jeremy, was we want to thread our string through the straw. To make a balloon rocket, we want to thread the drinking straw through onto the string. All right. All right, I'm going to set mine aside, and we'll use yours first, Jeremy. All right, and then what you want to do is secure the string. So what we're going to do is we're going to hold this string tight and make sure there's tension in between both ends of the string. And then we are going to, Jeremy, I'm going to let you start off. So you want to get some tape and put 2 pieces of tape onto the straw. So what we want to do is we want to get some tape and add 2 pieces of tape onto the straw. Next, what we'll do is we're going to blow up a balloon, but we're not going to tie it off. We're going to hold the air in the balloon. Okay, so to complete this process, we're going to attach the balloon to the tape on the straw, and we're going to extend the string out, holding the air in, pulling the string tight, bringing the rocket back towards you, Jeremy, and launch. All right. This is an example of transformation of energy from potential to kinetic. Thank you, Jeremy. As an educational coordinator, we like to promote energy efficiency and conservation. We like to teach you how to be smart with using the energy in your home. One great tip that I have for you today is remember not to waste energy. We want to make sure that we have enough natural resources to provide electricity for years to come. So that means turning out lights and unplugging electronics that we're not using. The more energy we use, the more resources we're going to have to provide for more electricity. Now, let me ask you a question. Have you ever considered working at Georgia Power? At Georgia Power, we believe you're never too young to start thinking about your career. Today, I would like to highlight the engineer representative position. With this position, you will be involved in service design, estimating and coordinating construction for multiple overhead and underground residential, new business, and construction projects. You will assist in the distribution planning of the power system for reliability. The starting wage is about $65,000 a year with advancement opportunities. Don't forget to visit our website at www.learningpower.org to watch cool videos and play games. You can also download our Learning Power app in your app store. We have enjoyed working with you today on the transformation of energy. We look forward to working with you again soon.